This is an interview with Luis Serrano. Luis has a Ph.D. in math and is an AI scientist, YouTuber, and author, all in AI. He's now building the Large Language Model University, or LLMU, at Cohere. This whole interview goes over the whole LLM University, as well as his background, great tips for teaching, and many other things related to prompting and large language models. I hope you enjoy this interview.
Hello, my name is Luis Serrano, and I'm very happy to be on your podcast, Louis. Thank you for the invitation. I've had a zigzag story, but I've always gravitated to being an educator. So my life started as a mathematician. So my goal was to be a professor. So I did undergrad and Ph.D. in mathematics, and I was a researcher for a while and then at the university. But at some point, I got interested in machine learning. So I started taking online courses, and I found it fascinating. I found that it was very much the similar to the math I was doing, but in a way that was so incredibly applicable. And so I switched gears and I moved to Google. And so I worked as a machine learning engineer in the recommendations team at YouTube, recommending videos. That was a lot of fun. But I always gravitate towards education. So I really enjoyed like teaching and everything. So I moved to Udacity. And for a while I was teaching the courses there with a great team, and we were teaching machine learning, deep learning, all these things. And that's a period that I learned a lot, and that's where I started the YouTube channel. I have this YouTube channel, Serrano.Academy, where I put all my material that I teach. I try to teach in a simple way because I always try to understand everything in a simple way, without formulas, without everything. And I also wrote a book at that time. It's called Grokking Machine Learning. And I continue in the education space, but in the tech education space. So I moved to Apple to teach. There's something called Apple University, where internally they would teach the employees. And so I was teaching machine learning courses there as well. And then I get different bugs that bit me. So I got bit by the quantum computing bug, and I got interested in that. So I moved, with the influence of a friend of mine who was a quantum computing scientist, I moved to Zapata Computing in Toronto. And I was a researcher in quantum computing, and I found it very fascinating. And also I started making educational videos on that as well. And finally, the last bug that bit me was large language models, because that's the thing right now. So after a few years as a quantum computing scientist, I switched to Cohere, where I'm working on large language models and also creating courses and educational material and all that. So we've created something recent called LLM University, which I think we'll talk about later. But that's my story.
Yeah, we'll definitely dive into the LLM University. But first, may I ask, what was the thing that bite you about LLMs? Why did you want to learn more about them and dive into this professionally?
Yeah, I mean, they really blew my mind when I was seeing the progression of machine learning, and I found that things were predictable, right? Like it was going fast, but I would say, okay, I think the next thing we're going to do is be able to identify this and classify that. When I started seeing how these models were talking like a human, it blew my mind. It was more steps than I thought would happen in that amount of time. And so I thought I have to learn this stuff. I mean, it really was a huge step. And so I got very curious, and I started asking friends and stuff. That's how I started everything. I started asking my friend Jay, and just all of a sudden I'm working on it.
Yeah, that's super cool. Yeah. And you also had the luck, well, not the luck, but you did a PhD, and you had the right kind of background to get into LLMs and just natural language processing in general, because you already were familiar with the field and the math and programming. But what would you say would be required to start learning about natural language processing and just AI in general?
Yeah, great question. I think any field works. So I was lucky to have done a lot of math without planning anything of going into AI, and it helps me visualize things in higher dimensions and things like that. For things like programming, I have to learn a lot, right? Like I have to constantly be learning, because that was not my background. And I think that's the case with everybody. I think everybody, not just for LLMs, but for machine learning, everybody has some background, some things they enjoy, some way they see the world. And that's very valuable to come into AI, because it enriches the field. So I wouldn't want only math people or computer science people in AI. I want them too, but I don't want just those, right? Like people with all walks of life.
Yeah.
And the data science teams that have been, the more diverse, the better, because the more, if you're trying to get this systems to sort of act like a human, you need all kinds of human, not just one type, right? So I find that the more diverse the team, the better. And so that being said, you do need some things to know. And every time every time knowledge gets sort of more democratized, and every time the technical barrier is smaller in terms of actual technicalities, like the languages get easier. Maybe many years ago, somebody would write in assembly, and now we don't. Now we write in Python, and every time the packages are easier, and now there's going to be a lot of prompt engineering. So the technical bar keeps allowing more people in, which I find fascinating. But I think if you know some basis of programming, that's necessary. So I would say one course in Python that gets you the idea of how programming works is good. And then the math, I think, is also important. But I defer, most experts would say, go home, learn all the math, and then come back and start, making a simple model for classifying house prices. I think that I don't agree with that. And I think you should definitely get an idea of the math to be able to train these models better and to be able to fine tune them, etc. But you shouldn't wait and learn the math before. You should learn it as you go. So I think people should get into machine learning by training models, by applying them to what they like, to the kind of problems that they are passionate about. And as they go, they learn the math. So they see a matrix, for example, in a neural network or something, and it's okay, I'm going to learn a little bit of that, but as you go. So that was a long answer, but the short one is, some programming, some math, but definitely going in and starting to practice hands-on. So if people want LLMs, just take a lab on LLMs and start working on prompting it and see how it goes.
Yeah, I also agree with being super practical is definitely more motivating, and you just end up doing more and learning more by building something that interests you. But if you want to become more of an expert, and maybe not expert, but let's say like you are aiming to work at DeepMind or OpenAI or really work in AI, would you say that this is a question that personally interests me just because I'm doing a PhD and I'm always thinking about that? But would you say that a PhD is worthwhile to do AI research and work in AI? And if it is or not, what would you say about your own experience with the PhD? Was it worthwhile, or like would you do it again if you were back then with the knowledge that you have now? Like, what do you think about the PhD?
Yeah, I think a PhD is like a personal choice. I enjoyed it. In the time I made the decision, I only knew pure mathematics, and so no applicable skills that I knew. I think I had them, but I didn't know I had them, and so I just knew pure mathematics. And the only way to stay in the eating while you're in pure mathematics would just be like do a PhD and then a postdoctoral fellowship and then a professor. I wasn't that fast, so I never questioned. I just said my question was where should I do my PhD, or like it was a small group, me and my colleagues were a small group, and our only question was where do we end up, or what kind of math do we do, or so it never the question never came to me. I'm thankful for it now. It was some of the best years of my life. It was stressing and there was a lot of work, but it was some of the best years I had. The things I learned in my PhD didn't really help me concretely. Like I don't use the actual things at all, but it gave me a few things. Like it gave me an intuition of math very strong because I was just doing it all day, right, for 5 years. And so kind of grinding power, like, I'm going to continue with this. And this, you're a PhD student as well, right? So some like, you just keep going, hitting the same wall until it breaks. So I think it gives you that, and it shows the employers that, right? Like if an employer is a PhD, they go, okay, this person can focus and has determination. So, but I wouldn't say people should do a PhD for the purpose of a certain job, unless that job is professor, which requires a PhD. But I wouldn't say that you need a PhD for an AI job, and even for a research job, I would say that it's not super necessary. I think an open mind, I think a creative mind, and sort of a love for tinkering and solving problems is really what matters. And there's a lot of ways somebody can get into the research fields without a PhD. They can start working as a data scientist and maybe get into some projects, do Kaggle, sort of then join a research team. I've seen a lot of researchers that don't have PhDs, so I don't think it's absolutely necessary. It's a personal choice, and it's fun. But I think there are other ways to get into research.
Yeah. And in these other ways, would you think that one can learn fully online and never go to a university or do a master's degree or more?
I think we're getting there. I think we're close to there. For example, everything I've learned in my life that's not math, I've learned it outside of the classroom. So I've learned it online. Programming, I learned some programming in university, but I forgot it. And all of the Python I know online, all the machine learning online. I think we're getting there. I think I think even if you learn in university, you still need to learn some things outside because things are so fast. You can't major in, maybe now you can major in machine learning, but by the time we get courses in LLMs in university, there's going to be a new thing. Universities can move as fast as the technology, and you kind of have to rely on online learning for that. Great thing would be a combination of the two, if you can do some university and some online. But I do think we're at the point that people can learn everything online, and that makes me happy because it means people who do not have the opportunity to go to university are able to learn a lot of stuff and contribute. I've certainly seen great people who just online learn a bunch of stuff and became geniuses of the field. So that makes me very happy.
Yeah, it's really cool. It's really cool how, well, the internet, of course, but AI also democratizes a lot of things that we expected the opposite. Like lots of people were afraid of new technologies like AI because it will make the rich richer and the poor poorer. What I feel like right now is that it's mostly the other way around, where it allows for a lot of people that don't know how to do lots of things to, for example, use the free ChatGPT application and just learn to code or use it to code or to do anything else. Like, it democratizes a lot of skills that you can now learn super easily or even apply without learning them. So I feel like it's really cool. Where AI is going is really cool. And what it also links with what you are doing with Cohere, with the LLM University. But before diving into this very cool topic, I'd also maybe want to cover some definitions. So, for instance, we often hear Gen AI or generative AI as well as LLM. And so I'd love to just first start explaining what those two are for you. So, for example, starting with, what is a LLM?
So actually, we get to generative AI, right? I think maybe I'll introduce it quickly and then talk about LLMs. I think what was cool like 10 years ago was classification, right? Like, if you could tell if this text is talking about something, or it's happy or something, or this image is a dog or not, and we were like blown our mind, right? And now it's like, that's a baby can do that. And now it's the opposite, right? Like, it's generation, like it's creation, right? You don't give that much information and you just give a bunch of data. It's harder, right? For a human, for example, answering questions is easy. If I give you a picture of a dog and I say, what's that? You say it's a dog. But if I say, draw a realistic picture of a dog, that's much harder, right? And so for computers, also much harder to just draw stuff or write stuff. And LLMs just do that, right? Like, they just generate text. But an LLM, I like to see it as a bunch of little moving parts. And all those parts are pretty simple, but put together and also thrown a lot of data and a lot of computing power, they just do magic. So I would say the main three parts are embeddings. Embeddings are really the most important thing in my opinion of an LLM, because it's where the rubber meets the road, right? It's where the computer starts talking. It's kind of when you translate to the computer, right? We talk in words, computers talk in numbers, and whatever you do, however smart the human is and however smart the computer is or huge, you need a good bridge. And if you don't have a good bridge, nothing happens. And the embedding is the bridge, right? It's what turns words into numbers. And the better the embedding, the better the models. If somebody comes up with a better embedding tomorrow, all the models get better, right? So you have to find a good way to turn words into numbers, not just one number, but like a series of thousands or hundreds of numbers that are similar if the word is similar, right? Like, if I say apple, you give me a bunch of numbers. And if I say pear, it gives me similar numbers, right? And if I say truck, it gives me different numbers, right? So embedding is a huge huge thing in a large language model. And then a transformer would be what sort of generates the text. And it's really a big neural network. Like I think with a bunch of padding on the sides, and I think you put a lot of little things like the positional encoding to tell the computer how the words are organized, etc. But it's just a big, huge neural network with like the ones we saw 10, 15 years ago, but with a lot of stuff. And then the important thing is attention. Attention is really what. So I already said embeddings are the most important. So I can't say attention is the most important, but attention is really what made this thing start working really well. It was like that one step, that paper attention is all you need. That's when they started working really well. And attention, what it does is it adds context, right? Because if I say, for example, if I say to you the word, apple, you don't know if I'm talking about the brand or the fruit, right? And no matter how good the embedding is, it's not going to know because it's a word by itself. And so what attention does is it starts modifying the numbers that are attached to the word apple based on the other words in the sentence. So if I say, please get me an apple and an orange, then you know what apple I'm talking about because the word orange pulls the word apple, right? So attention is what really gave context. And so now the computer knows what it's talking about, not just the words. This actually started gluing the words instead of just having a bunch of separate words. So I think to me, transformer attention and embedding are really the big three components of an LLM.
And lots of people want to not necessarily know more about large language models or LLMs, but mainly use them, like you use ChatGPT and do prompting and query them. Mm-hmm. But I think it's important to understand how they work.
Yep.
And based on the LLM University that you built and are building, I assume you think so too, but why would be the reason you think it might be interesting to learn and understand how they work in order to maybe use them better? But what's your motivation into trying to understand them?
I think it's kind of like a car, right? Like you can start driving it without knowing how it works. That's it. I don't need to know anything about the motor. I can just start driving it. And that's what people should do. Start driving, right? I don't need to learn the infrastructure of a car before I start driving. Now, if I start getting more serious and I start taking long trips, and one day the car is going to break, I need to know what to do. Maybe I want to become a race car driver. Like I want to really get into it. Now I really have to know how it works. If I want to be a Formula One driver, I need to know how every single corner of the car works and how the air goes and just absolutely everything, right? So certainly you can start the same thing with, I wouldn't say LLMs, but it's the same thing with all machine learning. But if you want to start working with LLMs, then definitely, you don't need to know the infrastructure of them. You just need to know how to prompt them and get stuff back, and then how to take the API call and put it in your code and your pipeline and everything, and then a little more. And then maybe you want to really run with them and fine tune them properly. So you need to know a bit of their infrastructure. And then if you want to be a Formula One driver of LLMs, a researcher or really, really build them and use them, then you have to know every single moving part, right? Like this attention goes here, this fine tuning goes here, and all that. So I think the farther you want to get with them, the more you have to know. But the entry bar is simply start prompting them.
Yeah, I definitely agree. And I assume some very rare people haven't even used ChatGPT yet. So what would you say is the best use or some very practical use case of large language models?
Yeah, definitely. What we've seen so far, we've played with ChatGPT or with the Cohere model or any of the models. It's something that talks to you back, right? Because that's the coolest application. It's just a chatbot that I can just ask any question and it comes back. So that's definitely an application. Another one is very important is search. Whether you're searching or whether you also want to chat, because as you've seen, like these models hallucinate, and sometimes you say something with full confidence, but completely wrong, and you don't know how to tell, right? So if you enhance them with search, then they can be accurate and give you where the information came from, etc. So definitely search is just one of the biggest applications right now. And then things like classification, for example, classification. That's like from 10 years ago we would use classification. but you would have to do like 10,000 examples to data points to train a model. With a good LLM, like with a good embedding, 4 or 5 are good to train a model, right? So that's also a huge application of LLMs. In general, embeddings, I mean, I think if you have a really good embedding, you can know a lot about your data. Like you can put your text into an embedding and it just tells you so much. Like it clusters it, it gives you a lot of insight. So I would say, yeah, definitely generate, which is talking, like chatbots, etc. Search, classification, and embeddings are some pretty solid use cases.
And who can, for example, chat, you can definitely just use ChatGPT right away. And for embeddings or classification, you can use the Cohere APIs.
Yeah.
But if you want to, for example, you have a data set or you have data in your company and you want to create some kind of chatbot linked with search and like memory retrieval system.
Yep.
Who could do that? For example, if someone is just an entrepreneur and knows basic Python or not even, like, can he build this kind of application using Cohere or something else? Is it accessible to anyone?
Absolutely, yeah. The Cohere generate endpoint works like a lot with ChatGPT, right? So it's the part that generates language. And so if you can apply this for your own data set. So if an organization has a particular data set where they want the answers to come from there, then you can plug that into a search model, right? That when given a query, it searches for the right answers and it gives you the where the candidates are, where the information is. And then you can use the generate endpoint to actually generate an answer out of this small set. So it's just much more accurate. So the search is for accuracy and then the generate is for like just telling the answer in a coherent sentence, right? So generate and search.
And if you are using APIs like that and basically tools that are already built, but you are merely implementing them, how is learning about them and, for example, going through the LLM University helpful to you if you are just following quick tutorials to implement them in your company? Can you do anything to improve them, or what do you gain by learning more about those models?
Yeah, that's a great question. The LLM University also has those tutorials, so it does tell you how to plug them in. Like there's a technical challenge, which is how to put these endpoints together, how to deploy it, all that stuff. But as you said, like if you're driving the car, you don't need to know how it works, right? So that part is no problem. But there are a lot of parameters and there's a lot of things you can do to an LLM, like to fine tune it and to just make it work better, including working with the embedding and putting things together. So if you want it to work really well, it's good to know some part of what's happening. So we also have tutorials on fine tuning, and people just kind of go as far as they want, right?
Yeah. You made a comparison with cars, and for cars, what we basically need is 2 hands, a leg, and just a lot of practice. But what is the base skills that you need to use LLMs in your company's website or application? Is there something that is required to learn beforehand?
Yeah, so you need 10 fingers and a lot of practice. No, I'm kidding. You need I think the more maturity you have with coding, the better. It's all about practice. If you've done data science before and you know how to train models and you know how to deploy things, and that helps a lot. But yeah, I mean, if you don't need to get into the details on LLM and you want to be a user, which is perfectly fine, then just maturity with code, just knowing how to plug this in your pipeline, and then maybe some intuition of what sometimes you have to put. Do you want to do this type of search? Do you want to improve it this way? So like a little bit of intuition of how the models work, but not you don't need to get into them.
And would you recommend any programming language? Would you say that if we give a concrete example, someone wants to build, for example, you give it a link of a YouTube video and you want to create an app that generates like a cool Twitter post about it. So what would you suggest people to learn about? I assume here Python isn't really the language that you are looking for there. Yeah, like it's mostly front end and then just what it's needed to connect API? Can you do everything with Python? What would you recommend to go for?
No, I mean, I would say people should learn the language that they need for their application, right? Like if somebody's just going to work on LLMs, definitely I always recommend Python because its packages always come first in Python, etc. But if somebody is working on front end or something, then definitely that's the language they should learn first. You can always sort of put things together.
Another very important thing or new concept is prompting. And I wonder what you think about it. I will first say what my intuition with prompting, and please correct me or just say if you are not in agreement with it. To me, I don't know. A lot of people say that prompt engineering is a job of the future and it's like how we will do everything. But I feel like it's not really the future. It's more of a transition, because right now I feel like, as you say, the better embeddings that we have, the better the models will be. And right now, since they are not perfect, we still need to do good prompt engineering to prepare the English language to the model. Yeah. And so I feel like the more we advance towards better embeddings and better models, we won't be needing to be good at like preparing the prompts for the models. And so I feel like in the end, large language models and just AI in general will be just super easily accessible with a very simple query that anyone will do. And so I'm not sure I agree with the fact that prompt engineering is a job of the future. And I would love to know what you think about that.
That's a great point you make. Of course, these things change so much that I'll be, whatever I say, we could be listening to this podcast in years being like, oh, how did I ever think of that? I don't know. I mean, I find that the only thing that's constant of the future is that it's going to be changing all the time, right? So I think it could be that prompt engineering is the job of the future for 5 years until the next one, right? But maybe the same thing happened with data scientists, right? Like it was the job of the present. Maybe we're not going to need it because these models are going to be much better. So maybe it is the job of the future for a little bit of time. I think there's two schools of thought. I think there's the one that says prompt engineering is the data scientist of the future. Yeah. And another school of thought that says that prompt engineering is just going to be like what fine-tuning models is right now, right? Which is important, but you don't get a job as a model fine-tuner, right? It's a thing you do among all the other toolkits of things in a data scientist. So I think my opinion is going to be big. As you say, there's going to be a day that we may not need to prompt correctly the model because the model will know much better. But I think the level at which we communicate with the computer is going to get higher and higher and higher. You know what I mean? Like the previous generation, parents did assembly, Now we write in Python, which is just much clearer with actual words and stuff. Maybe the next generation will speak in words to the computer and they have to figure out the right words to put it there. But maybe in the future, the words don't really matter because the computer will know what you're doing, what you're talking about. But there's just going to be some higher level of structure that you need to have in order to do things properly, which is what jobs that don't require computers do, right? Like you still speak in English or in French or Spanish, the language that you speak, but you need a high level of comprehension, right? Like a CEO never codes, but they only speak words, but they need to have some structure to the words they use, right? And I speak the same words, but I would not know, how to handle certain level of things as someone else. I think our level is going to get higher and higher, and the next thing will be prompt engineering, and the next thing would be just someone who thinks in even higher level than a prompt engineer. So, yeah, but we'll see.
So you are still quite optimistic about prompt engineering in general?
I think so. I mean, who knows what will happen, but I do think these models are going to be more and more ubiquitous, and somebody who knows how to prompt them correctly is going to be the sort of the next job. So I think it'll grow.
What is the secret to prompting them correctly? Is it just like driving a car and it's just sheer practice, or do you need to learn more about the models, or learn more about embedding specifically, learn more what do you need to learn or to do to be a better prompt engineer?
Yeah, I'm kind of learning it as we speak. So I mean, I think knowing about the math inside the model may not be super helpful, but knowing how they behave with certain things, it's kind of like being good at Google searching, right? Like you can add some things and put some sentences in a way that's much better, that gets you the results better than somebody who maybe just bump into Google for the first time, right? So I think it requires a bit of that and a lot of practice, a lot of knowledge of what you're trying to get, right? Like the whatever your application is, you also need a lot of knowledge of that. So at the end, that like if you're opting it for a medical application, you need to know some part of that too. But yeah, I mean, practice also. I mean, chaining prompts, which may be lost, right? Because it may be something that the computer figures out. But for now, I mean, I think chaining prompts is very, very useful. Like you make a simple prompt for something, and then turn that into something else. Like if you want to build, for example, like a very elaborate story or something, maybe in a few years the models will be able to build it. But right now it could be you build a story with one prompt, and then you add some things with another prompt, and then you add chapters and characters and stuff like that. So I think it's a lot of practice and a lot of sort of high level knowledge.
And who do you think should learn about AI? I will try to give a concrete example just to challenge you a bit. But for example, I have a friend that is a recruiter in a specific company. So he's looking for people to fill in roles in the company he's working at.
Yeah.
And so, for instance, him using LinkedIn and going through CVs and interviewing people, what could he do with AI with the knowledge that he doesn't know anything about coding and Python and anything? He did like human resources and went right to work, but he has an interest in AI, for example, and wants to improve his work or like be more efficient. I assume that it's definitely beneficial for him to learn more about AI, but what could he do exactly? And could you give him a road to follow and what would be the expected results?
Yeah, absolutely. So first, let me get to the first thing you said. If should people learn AI? And I think I remember when I was a kid. I think I'll reveal my age, but when I was a kid, people were saying, "Oh, should we learn how to use a computer or not?" And now it's not even a question, right? Now kids know how to use a computer before they talk and just play with apps and stuff. And then the question was, should I learn how to use the internet or not? And now it's not even a question, right? And I think AI is going to be that in the future. Like, should I learn how to use AI? It's going to be all over the place, and so many tasks that are repetitive we're not gonna learn how to do. Like right now you and I cannot make fire with 2 rocks, but at some point that was the one thing that everybody had to know, right, to survive. And so in the future, I mean, there's going to be a lot of repetitive tasks that people are not going to know how to do, and we rely on AI for those, and that's okay because we're going to move to higher and higher grounds in terms of our thinking. Now for your friend, I mean, I think recruiting is the perfect example of somebody who should get into AI without getting very technical. I think a recruiter can use some model or you prompt some model or train something simple to be able to go through, instead of 5 resumes or 10 resumes, go through 1,000, right? So that part is the easy part. I would say that being able to train a model to get you good candidates is certainly something simple that you train using all the resumes of people you've hired and all the resumes of people you haven't hired, and just get it to find patterns and stuff. But where your friend's skills come in very handy is actually the part that's not AI, right? It's actually the part where you want to make sure that this model has no biases. Like recruitment, AI for recruitment is one of the places you need to work the hardest, because the biases that have come in the past, that sexism, racism, they explode. They just basically those behaviors get multiplied. And so as a recruiter, they have to know, sort of from seeing a lot of resumes, what kind of things are correlated, what kind of things should you look out for in your model, what mistakes is it making, how to fix it. Is not just deleting the name because or the demographics, because a lot of stuff is correlated in the information that the model may pick up and continue with these biases. So I think your friend can not only benefit from AI to do their job much faster, but they can also, come back and input some things and be like, okay, this model it's making these mistakes, let's fix them.
You mentioned that one of the simplest things would be to train a model with all the CVs and to help him process them. But is there any other way, not requiring him to train a model? Because here, for training a model, he will need to start learning Python and then try to learn how training works, regularization, and everything related to training. Yeah. So is it possible to use something that is pre-built with either already knowing what is a good CV or not, and you can just prompt it, or to give it some kind of database that you have of CVs that just is an easy web application or something that you can just upload your CV and it will work? What can he do if he doesn't have any programming knowledge?
Yeah, I'm sure your friend can do this without writing a line of code. I don't know off the top of my head, like places like that, but definitely there's many places where you can use pre-trained AI models and input your files and stuff and get the model to work. So I don't think they need to write a line of code. Certainly don't need to do regularization or anything of those along those lines, like using pre-trained models. They already are fine-tuned. So I would say go check out APIs and check out AWS, things like that. And that's even before LLMs, right? That's something you can do right away. With LLMs, I mean, I think one thing you can do is few shot learning, right? Like, as I said before, to classify things, you don't need 10,000 examples anymore. You need 4 or 5, right? And so if you use an LLM and you can just say, hey, check this out, LLM. These 10 resumes, good. And I'm just going to paste them there. And these other ones, bad. So I'm just going to paste them there now. And it already will start giving you results, right? The more you put in, the better it'll get. But as I said, with embeddings that are so good right now, the model will be able to sort of pick up what's a good and a bad resume, and without writing a lot of code, right? You just put them in.
Yeah, it's really cool. And basically, the only skill you need to have is, as you said, one that we all already have without questioning, and is like how to use Google and internet.
Yeah,
basically
common sense.
And is there a job that does not require to learn about AI? Is there some people that should not even think about artificial intelligence or try to understand what it is, or is it relevant to anyone regardless of their background?
I have a hard time finding. I'm sure there are, but I have a hard time, and it's one of those things that if I say one job and we listen to this podcast in 6 months, they'll be like, Louis, shut up, that job already has AI. No, I think we can. It's like when the machines came and we start using them for things at home or for our job and stuff like that. I think we're gonna end up using AI for everything, and I think like it's gonna take the mechanical part of our job away. And every job has a sort of intuitive side and a mechanical side, and maybe we don't really know exactly which one it is. But the answer is whatever the machine can do is the mechanical part, and whatever we can do is the intuition, right? So I think, and a writer can come up with the idea of the story. That's a lot of intuition, and then the wording and the writing is the mechanical part. So they can use a model to help them with that. An artist, same thing, right? We see, for example, architects don't draw with pencil anymore. They just use a lot of modeling tools and stuff like that, but they still think of the building in their head. So I think I have a hard time thinking of a job that doesn't. But I would say the hardest part for a model is anything that requires sort of emotional intelligence. Like I think leaders, I think, anything that requires empathy or like, group thinking. I think those are the last ones to go. Like those are the highest level. And those, you can use AI as a tool, but AI is not going to make those decisions. AI makes decisions when it comes to maximizing or minimizing a number, right? Whatever they do, the minimizing number of mistakes or the number of time or maximizing the number of things it went right. Decisions that require empathy and emotional intelligence, many times there's no number you're maximizing. You're just thinking as a human. So I think those are the ones that will be the hardest for a machine to do.
And likewise, I would add that models merely interpolate from the data and they cannot really extrapolate. So it's also hard to innovate or create something new, even though sometimes the image or text generated seems new. It's mostly a blend of what already exists, which is also what humans do, but we can still innovate a bit more than that, I believe.
Yeah, it's hard to tell how much of what humans do is interpolating from what we've seen before and how much of it is new. And I think, if anything, all this technology is going to extract that, because there's got to be some things that we'll discover that the machine can't do, and that may just be the one thing we add. Yeah.
And speaking of large language models, we discussed a lot of topics that are very relevant to what you are building at Cohere. So I would love to just dive a little bit more into what you're actually doing with LLMU, or Large Language Model University. And to do that, could you maybe give us a brief overview of what it is exactly, what you're covering, and the main insights people could expect when going through this university?
Absolutely, yeah. I'm so excited of LLMU. It's just been a blast working with it. And since we started it, we just decided, we want to bring everyone up to speed in LLMUs in every possible way. And obviously, it's material that you can go at your own pace. You can pick this, that, or that, or you can go over it in order. But the idea is just to have everything. And I always just like to understand things in the most simple way. So I don't have a formula. I don't have a matrix. I just have little, words lying around and cars and fruits and stuff like that. That's what Module 1 is, right? Module 1 is like a friendly introduction to LLMs. So we talk about embeddings, we talk about attention models, similarity, basically the architecture of a transformer. We get through the architecture of a transformer. And also talk about things like semantic search, which is embeddings. But it's all conceptual. Like, it's all, to get you an idea of what's happening behind the computer. Don't worry about the matrices and the numbers that get multiplied. Just know, what's under the hood in a big way. And then we have modules 2 and 3, which is 3 is based on text representation, which is basically anything that's not generation. So then we have search, classification, embeddings. Then there's a lot of labs, right? So this one has basically code labs with the information behind. With all of it has blog posts and videos and code labs, but it teaches you how to use the endpoints and how to analyze things. So, for example, it makes you embed a big data set using the endpoint, and then once you're in the embedding, cluster it, see what insights you get, et cetera, et cetera. So that's module 2. And then module 3 is generation. So it teaches you how to use the generate endpoint. And then it teaches you sort of like a lot of like prompt engineering. It has a lot of labs. So one of them is like, building a story, what I was saying before, chaining prompts, a lot of use cases of where would you use generative learning, et cetera. That's what we have right now. And we are adding a lot of content. So the next module we'll be adding pretty soon is deployment. So we have a model on deployment on AWS SageMaker and a lot of other things. The Cohere endpoints are sort of cloud agnostic. So we have examples on how to deploy on most platforms. And then we're adding an entire module on search, because search is basically like one of Cohere's greatest focus is, and where a lot of the innovation has happened, and where it's the leader. And so we're gonna add an entire module on like a lot of different search applications and technologies. So retrieval augmented generation, which is what I'm saying, that you can first search and then generate answers from there. Re-ranking, which is a step that makes searching much better, and a lot of these technologies. And then another thing we're adding is more prompt engineering, because that's what everybody wants to learn. So we have a lot of great material on that, and we'll continue adding things. In the future, we'll add things on enterprise type of content, like a decision maker in a company doesn't need to know so much about the models or something, but they need to know the high level. What should I use? What kind of team should I build? Et cetera, et cetera. So yeah, we're always adding stuff, and we have a lot of cool events. Discord channel is very, very active. We have monthly talks. I give them sometimes. The other instructors, Jay and Mior and all of them, they also give them, and we have just a lot of activity in the community, office hours, etc. So it's been a lot of fun.
Yeah, it's super cool. And I also just want to clarify that you mentioned a lot of relatively complicated terms, or terms that people might not be familiar with, just for example clustering or re-rank or any terms related to AI and large language models. But I wanted to clarify that this is still a course for anyone to jump in and learn. Like, you go through as if it would be a beginner, and like anyone should be fine going through it, right?
Absolutely. No matter what level of beginner. We have some material that's sort of introductory in ML that you don't need to for LLMs, because everything we use, we introduce. But if people want to go through the basic ML material, they can as well. And we have links for everything. So for example, clustering, which is really just grouping points. We have a resource for that. We link to a resource of that. We basically link to a resource on everything. And there's very little that is needed to get up to speed here. And so if you want to go to the code labs, basic Python, and then basic math, but I never use a variable. I just use numbers. So 3 plus 4. I don't say x plus y. I say 3 plus 4.
It's completely free, right?
And it's completely free. Yeah. And you can go in, and it's completely free, completely open. And you can go, we have a suggested order that you can just go next. But if you want to really learn this one thing, you can jump into that one thing and go at the pace that you want. And we have sort of, we don't have cohorts, but the Discord channel, we do kind of like, have people studying together. We have study groups. We kind of make it as community as possible. But certainly this is growing. It's got a lot of great reception. So many people have replied, have joined the community, that we're definitely putting the accelerator on it. And our goal is to make it into with an infrastructure of a course. And so yeah, we're getting there.
Awesome. I definitely recommend just at least trying or starting to read the initial courses and modules of the LLMU. But just I want to clarify another thing. When you say Discord, is it the Cohere Discord, or is there some...
Yes, great question. It's in the Cohere Discord, and then there's a small community for LLMU.
Perfect.
Yeah.
And yeah, I've seen your videos about embeddings and transformers, and it's amazing how you explain stuff, and you are a really good teacher. And so I just wanted to diverge a little bit into the teaching world, just because I feel like whether you want to teach to people or are working in a company and need to do a presentation or talking with teammates or colleagues, you always need to explain, or at least make your thoughts sound simpler and clearer. And so I wonder if you have any tips to better explain concepts or things that you work on with all your experiences with YouTube and Cohere and your work at Apple and everything you've been in the teaching industry.
Yeah. Oh, great. Thank you. That's a great question. Actually, everybody has their own way to learn, right? Like, some people build things, some people have to write all the details. I learn by teaching, and even the times in my life where I've tried not to teach and I've just done a job that's completely not requires teaching, I always gravitate to teaching because that's my way of understanding things. And as a matter of fact, it stems from difficulties. I have difficulties learning all my life in school. I was just lost in class. I get distracted very easily in meetings and talks. If you ever see me at a conference, just watch me. I'm like this because I get lost easily, right? And so when I see a talk that's full of formulas, I kind of have to, either I'm lost or I completely try really hard to understand it with examples, with a simple example. And so my first advice is check out your weaknesses, because there may be a hidden strength there. When I teach, I have to talk to the slowest person in the room, because that's me, right? Like, if I understand it myself, everybody will, because it just has to be at a level of simplicity that even I don't get lost, so I get lost in everything. So I explain to myself. Concrete tips is definitely don't take things for granted. I mean, I think people have, in academia and in industry, there's a bit of an ego where you have to sound professorial and you have to sound elevated. And I think nobody likes that. I mean, we pretend to because everybody does. But I think, people are scared that if you go and say something too simple, people will laugh or think they're stupid. I guarantee that's not the case. I've said simple things for years in front of everybody. As a matter of fact, I have a hard time trying to say things complicated. Like if I try to sound technical, I can't. And so I guarantee nobody thinks people are stupid if they say something in the simplest possible way. So always try to find the simplest example. I always ask myself, what is the simplest example that I can have in order to illustrate this concept? So I'll give you an example. Image recognition. I could explain image recognition as like you have a huge matrix of pixels and that's your image, and you multiply it by a vector, and then you apply an activation function and da, right? Well, if the image is 28 by 28, why not make it 2 by 2? And why not make it black and white? So all of a sudden, I have 4 numbers, right? And if I can explain, I don't need to multiply this matrix by a vector. I actually can do all the operations. So I go, this is gray, it's 0.5. This is white, it's 0. This is black, it's 1, right? Like I can do it with actual numbers, and somebody who doesn't know a matrix or a vector or matrix multiplication can follow because they know how to add 1 plus 0. You know what I mean? And so I always try to bring it down to the simplest possible example. And if I can find an analogy, that's always good. Because here's something that happens, right? Like people always say they're bad at math, but that's not true. People are great at math. You could not survive if you were not good at math or physics. The logic to go around the world and figure out, if this is open from 2 to 4 on Saturdays, but not on Fridays, and today is Friday, like that logic is the same logic as math, right? And physics too. If I tell people to draw a kid jumping, they would draw a parabola. They know. But if I tell them to draw y equals minus 9.8x squared, they wouldn't know. Because what people are bad is not at math, it's at abstraction. And what most of education unfortunately does is that it takes the reality away from things, and it gives you something really abstract and then teaches you that, and that's, you cannot appreciate it, right? Like if I take a song and you're hearing the music, instead I just take away the music and give you the notes, we wouldn't know, right? Only the experts would know. And so I piggyback on people's knowledge. Like people know how to operate the world. And so therefore I'm not going to give them a formula. I'm going to give them a real life scenario where that formula appears hidden, and tell them, what would you do here? And they know exactly what to do here. And then I say, okay, in this formula, what you did was this, right? So always, basically, advice for teachers, be humble with knowledge and with your peers. Don't be afraid of sounding stupid by being too simple. That's not the case. And always try to piggyback to reality and to the simplest possible example that illustrates things.
Thank you. Those are really good tips, especially the sounding too simple. I think that's one thing that I still need to get over, just because I recently had like a presentation for my PhD, and it's indeed relatively hard to know for those presentations when you don't really know the audience exactly, like who will it be. It's hard to know how high level or low level you need to be. And it's also, you are also in front of some professors and some postdocs and like experts. So it feels like you don't want to look like someone that is dumb or take them for dumb people by explaining like the very basics of a convolution or something that is essentially simple for them. Yeah, to me, it's hard to get over that fear of like not disappointing, but of sounding that I'm over explaining stuff and that it's simple, just get to the next step. I think you are right that it's definitely worth to still mention, even if it sounds super simple.
Especially when I was in my PhD, I had that problem because I think everybody in grad school has that imposter syndrome, right? So you felt like I'm the only one here not understanding, or that I'm explaining things and something that everybody knows. But then you start talking to others, and for example, in a conference in math, I would just quietly say to someone, I didn't understand anything, and they'd be like, me neither. But they sounded like they knew everything. They just looked so confident, right? And then at the end, it's just everybody's feeling like that, So a little bit of, I was thinking a little bit of kindness can go far. And if you just talk the grad students will understand or that the undergrads will understand, then, if one professor got offended because you were not too simple, then let them, I always say my talks to undergrads and grad students.
Yeah. And it's crazy how this is so true, where in most conference I go, even in CVPR that I will go in next week, but I went there last year, and some talks that we attended, I watched my friend, and they seemed to follow, and I was the only one that seemed lost. But at the end, they had no idea what he was talking about. And it was just always like this. And at the opposite, I never talked to someone and said, or he said, this was too simple. This never really happens. Worst case, it's simple and it was just a great refresher or something, but it's not. It cannot be really too simple. It's even for example, I've seen Jan LeCun's talk a lot, just because he reuses relatively the same talk, and it's relatively straightforward and simple, but it's still interesting every time, and nobody says this is too simple and useless. It's still interesting, and you can then get a bit deeper, but going through the basics and starting over is definitely useful and even maybe required to be understood and to be interesting.
Yeah, absolutely. And sometimes I even have experts saying, because experts think in a very high level and always stay here, right? And they talk here and they understand here. And every now and then, sometimes an expert comes and says, wow, you actually brought it down here and gave me more understanding, something I already understood. But if you bring it to simple, they may have never done that before. Maybe they've always thought about it in high level. And if you give them a different spin, a different way to understand things, you're still adding to them. So you gave the beginners a great overview of what you were working on, and the experts a great dive into something. So that's how I try to aim it, so that I don't bore the experts, but I also don't teach the beginners.
If it's interesting enough, and just your great car comparison, for example, or any low level or high level view that is innovative and interesting, that catch your attention, that's also first really good as an expert, just to I basically will steal your idea, just because it's easier to explain what I do to other people, just because you explained it so well. And it may also be good for researchers to think about their problem differently and maybe come up with another type of solution just by reframing the problem, basically.
Yeah, it's always good to understand things at their basic level. I find that when I do research, I have to do that, because otherwise I don't get them. I don't understand high level, but I sometimes find that when I talk to researchers and I force them to come to my level of examples, new things come up, because you're seeing it from a different angle, right?
Yeah. And keeping in the teaching world, you've been in this world in machine learning for a while. Have you seen a difference, especially, for example, with your experience on YouTube or elsewhere, but have you seen a difference in the people wanting to learn about AI, a difference in profile or was it, for example, before it was only students wanting to become researcher, and now it's entrepreneurs wanting to create applications? Is there a difference in the people wanting to get into the field and learn about AI?
Humongous. Yeah, I mean, when I started in AI around 10 years ago, it was only programmers and statisticians who got interested in this, and they would just go in and it, you would be solving problems outside of the field using only your knowledge in programming and statistics. So obviously you're missing a lot of things, right? There's a problem in medicine, and you approach it with machine learning. You can only get so far, because no doctor's looking at it, right? But now just everybody's interested in AI. Now everybody wants to come with their own level of expertise, with their own expertise and their own knowledge to contribute to AI and to be benefited by it. So I've seen that it's no longer a field. It's now so ubiquitous that it's more before I do AI. Okay, now it's I do AI with this. Nobody just does AI. You do AI with some flavor or some application to this and that. And now the question is not, do we do AI or not, but what do you apply AI for? And it's a two-way street. I think anybody that comes with a new field and applies AI to it contributes to AI, So that's one thing I love.
Yeah, it's an amazing new field. It's just unbelievable where now, as you mentioned earlier in this discussion, people can come from linguistics or arts or like any background and be helpful in creating a better model. That's so cool. It's not like reserved to programmers or mathematicians. It's amazing.
They have their own way of thinking. I worked with musicians, with artists. Chess player, for example, I met one of the best AI 2.0, and there are a lot of people.
It's really cool. Yeah, those were all my questions. So I definitely invite anyone listening to check out and get into AI by going through the free LLM University from Cohere, and also join the Discord, just because the events there are also free. And otherwise, I would like to ask you if you had anything else that you are working on or personal projects that you would like to share with the audience.
I always have my teaching projects, which I'm very passionate about. So definitely, I invite everybody to check out the YouTube channel, Serrano.Academy, like my last name, Serrano.Academy. On YouTube, I have a Spanish version as well and a Chinese version as well. So very, very kindly translated a lot of my videos. And so Serrano.Academy, definitely check it out. That's where I put all my knowledge. The book, Grokking Machine Learning is where I explain all the machine learning in the way I like it, in the way I understand it. And then I recently got a specialization out with Coursera and deep learning AI that I'm doing. And it's called Math for Machine Learning Specialization. So there I teach like the math that people need to know for machine learning. And it's 3 courses, each one of 4 weeks long. Linear algebra is the first one, calculus, and the third one is statistics and probability. And it's all geared towards machine learning, like picked all the topics that were basically going to be used in machine learning or give you some kind of insight. So gradient descent, things like matrices, rank, hypothesis testing, probability, like maximum likelihood. So if anybody, I recommend it for people who are in AI and or getting into AI and trying to learn the math on the side. So yeah, check it out.
Really cool. I didn't know you recently did that. It's really useful, and I definitely also recommend it if you are going for a job in the AI field. Like if you are aiming for a job or for doing a PhD or a master's. Personally, I did. I just went through the classic engineering university background, and even then, during my university, I still took online courses about math and all those topics. So I definitely also, even if you are in university, recommend to check those out and just get better by yourself. It's definitely worthwhile, and I'm sure those resources are just as good, if not better, as everything you do on YouTube and Cohere. So super. I will also check those out and maybe add to my. I have a guide for getting into AI online, so I definitely will check those out.
Thank you very much.
And, of course,
and I'm a big fan of your content and your channel as well. So it's an honor to be talking to you.
Thank you, and thank you very much for all the amazing insights that you gave. It was a super fun discussion for me, and I'm also a fan of your YouTube channel and your work. So that was really cool for me. And yeah, thank you very much for your time and for all the great insights that you shared with us.
Well, thank you as well for the great conversation. It's great questions you asked, and I'm very happy to be here.